Hello friends, welcome to aimstoday YouTube channel. In this video, we are going to discuss about IIT-JEE NEET Foundation Chemistry Atomic Structure chapter from this spectrum. The light that we see from sun or in an incandescent filament lamp is a white light. White light is composed of 7 component colors, namely violet, indigo, blue, green, yellow, orange, and red, as shown in this figure. The splitting of this white light into its component 7 colors is known as dispersion. The array of 7 colors extending from red at one end and to violet at the other end, similar to rainbow colors, is called spectrum. Atoms, molecules, or ions that have absorbed radiation are said to be in excited state. The radiation emitted by these excited substances form a spectrum. So, the light emitted by a sample of excited atoms is called atomic spectrum. A sample of a gas containing an enormous number of atoms. Although a single atom can be in only one excited state at once, the collection of atoms contain all possible excited states. The light emitted as these atoms fall into lower energy states is responsible for the formation of spectrum. It is important to note that such a spectrum consists of bright lines on a dark background. This is an emission spectrum or emission line spectrum. Hydrogen spectrum is the simplest of all atomic spectra. When an electric discharge is passed through hydrogen gas at low pressure, a bright light is emitted with a spectrometer and is found to comprise a series of lines of different wavelengths. Some of the lines are present in the visible region, while others in ultraviolet and infrared regions. The hydrogen spectrum consists of several series of lines named after their discoverers. The first of these series was discovered by Balmer in visible region. Only this series is visible to naked eye, and hence it is called Balmer series. Balmer series is obtained when an excited electron is jumped from higher orbits to second orbit. Balmer showed that the wave number of any line in the visible region can be expressed by a simple empirical equation which reads as nu bar is equal to r into 1 by 2 square minus n square 1 by n square centimeter inverse, where n is the number of the higher orbit from which electron jumped to second orbit. That is, n is equal to is greater than 2, that is 3, 4, 5, 6, and so on. And it might be. And r is a constant called Redbox constant. The value of Redbox constant for hydrogen is equal to RH is equal to 109677 centimeter inverse, or 1.09677 into 10 to the power of 7 meter inverse. The wave numbers of different lines in this series are obtained by substituting n values. Lyman series is Lyman observed from some more spectral lines of hydrogen emission in ultraviolet region. Similarly, Pascal, Rocket, and Fund observed separately 3 different series of lines in infrared region. Different spectral lines of hydrogen emission are shown in this figure. You can see Balmer series in the visible region, Lyman series in the ultraviolet region, and these 3 Pascal, Rocket, and P-Fund series in the infrared region. Redbox gave a more general expression which can be applied to all the series of hydrogen spectrum. This expression is called Redbox Formula. That is, nu bar is equal to 1 by lambda, that is equal to r into 1 by n1 square minus 1 by n2 square centimeter inverse, where n1 and n2 are whole numbers and n2 is always greater than n1. And n1 is the number of the lower orbit to which electron jumped, and n2 is the number of higher orbit from which electron jumped. For one electron species like He plus Li plus 2 and Be plus 3, the value of R is given as 109677 into Z square centimeter inverse, where Z is the atomic number of the species. The wave number for any single electron pair like this can be calculated by using the formula nu bar is equal to Z square into RH into 1 by n1 square minus 1 by n2 square centimeter inverse, where Z is the atomic number of that single electron species, and RH is the Redbox constant for hydrogen. So different series of spectral lines in hydrogen spectrum are shown with the diagrammatic tabulated here. From this you can say Lyman series is obtained when an electron jumped from higher orbits to first orbit. It is obtained in the ultraviolet region. And Balmer series is obtained when an electron jumps from higher orbits to second orbit. It is in the visible region. That means this is the only series which is visible to naked eye. Fascon series is obtained when an electron jumps from higher orbits to third orbit. It is obtained in nearer infrared region. And Brocket series is obtained when an electron jumps from higher orbits to fourth orbit. It is obtained in the middle infrared region. And P-Fund series is obtained when an electron jumps from higher orbits to fifth orbit. It is obtained in the further infrared region. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.